Okay, dear students, now I am discussed about wave optics. In previous class, we have discussed about ray optics. What is ray optics? It is the branch of physics deals with the study of rectilinear propagation of light and image formation on the basis of a ray concept of light. It's called ray optics. What is then wave optics? Wave optics is the branch of physics deals with the study of phenomenon exhibited by the light by using Eigens wave theory and Maxwell's electromagnetic theory. It's called as wave optics. Before studying the wave optics, we have to discuss about different theories of light. Different theories of light. First theory, Newton's corpuscular theory. Newton's corpuscular theory. According to this theory, light emits minute particles in the form of corpuscles. They transfer energy. Corpuscles or transfer energy in the form of kinetic energy. This Newton's corpuscular theory was successfully explained the reflection and refraction of light. But it was failed to explain speed of light in rarer medium is more than the speed of light in denser medium. According to this theory, the speed of light is more in denser medium than rarer medium. But later was experimentally proved by speed of light is more in rarer medium than the denser medium. Newton's corpuscular theory was failed to explain the speed of light in rarer medium is more than speed of light in denser medium. Second, Eigens wave theory. Eigens wave theory. According to this theory, the light propagated in the medium in the form of mechanical waves or sound waves. They produces disturbance through hypothetical material medium called ether. This theory was successfully explained reflection, refraction of light, and also successfully explained the speed of light in rarer medium is more than the speed of light in denser medium. But this theory was failed to explain. This theory was failed to explain to prove the existence of ether. This theory was failed to explain to prove the existence of an ether. Next theory of light, Maxwell's electromagnetic theory. Maxwell's electromagnetic theory. What is this theory? According to this theory, the light consisting of time-varying electric and magnetic field vectors are oscillating mutually perpendicular to the direction of propagation of waves. Like this, time-varying electric and magnetic fields are oscillate mutually perpendicular to the direction of propagation of light. Light has a transverse nature. This theory was proved light has transverse in nature because of the time-varying electric and magnetic fields or oscillate perpendicular to the direction of propagation of waves. This theory was successfully explained the phenomenon of diffraction, refraction, and interference of the light. But this theory was failed to explain the phenomenon of photoelectric effect and Compton effect. Next theories of light. Fourth theory of light, Planck's quantum theory. Planck's quantum theory or Einstein quantum theory. In quantum theory. According to this theory, light consists discrete pocket of energies or light radiation contains or consists discrete pocket of energies or called as photons. The photons are travel at the speed of light in a straight line. This quantum theory was successfully explained the phenomenon of quantum effect and photoelectric effect of light. But quantum theory was failed to explain diffraction, interference, and polarization of a light. This is now quantum theory. Next, de Broglie theory. De Broglie theory or dual nature of light. Nowadays, light has a dual nature. It's having particle nature as well as wave nature. According to the Maxwell's electromagnetic theory, light has wave natures. They exhibit diffraction, interference, and polarization of light. According to the Planck's quantum theory, light has a particle nature. They exhibit photoelectric effect and Compton effect phenomena through the particle nature of the light. Different conditions, light behaves like a different properties, particle nature as well as wave natures. Light has dual nature. Next, wavefront. Wavefronts are locus of a point which have the same phase of oscillations. Which have the same phase of oscillations or vibrations. Wavefronts are the locus of points in the source of waves or light which have the same phase of oscillations. All points of the waves or oscillate with the same phase. Those are called wavefront. For example, when a stone is dropped on the conch full of waters, the concentric circular rings are originating from the point of impact. All points of the concentric circles are oscillate with the same phase. Those are called wavefronts. From the point of impact, number of concentric circles are formed. The crest of the all concentric circles are oscillate with the same phase. What is the meaning of same phase? Phase is the both position and direction of the particle at any instant of time. The same. But both position and direction of the particle at any instant of time is there in same path. Is called phase. Because of the crest of the all waves of the concentric circles are oscillate with the same phase. Means all are same moment. Crest of the waves in the waves. Those are called wavefronts. Types of wavefronts. Types of wavefronts. First one is spherical wavefront. Spherical wavefront. The wavefront from the point source at a finite distance is called spherical wavefront. Wavefront from point source at a finite distance. Source at a finite distance. Source is called spherical wavefront. Wavefront from a finite distance source. Wavefront from point source at a finite distance, or the finite distance source is incident on the spherical surface. Emergent wavefront is a spherical wavefront. For example, this is the source of light is incident on this spherical surface. These are the emergent wavefront from this source. These are spherical wavefronts. Emergent wavefront or spherical wavefront. The source of light is finite distance from the spherical surface. The emergent wavefront are called spherical wavefront, or the finite distance source is incident on the spherical surface or point source. These emergent wavefront are called spherical wavefront. Next, cylindrical wavefronts. Cylindrical wavefront. What are cylindrical wavefront? Cylindrical wavefront. What are cylindrical wavefront? Source of light from the cylindrical surface at a finite distance, or wavefront from cylindrical surface, or narrow slit. Wavefront from cylindrical surface or narrow slit at finite distance source. Finite distance source, or called cylindrical wavefront, or is called cylindrical wavefront. Means the finite distance source is incident on the cylindrical surface or narrow slit. The emergent wavefront is called cylindrical wavefront. Emergent wavefront is called cylindrical wavefront. For example, this is the narrow slit. The source of light S is incident on this narrow slit. These are the emergent wavefront. These are cylindrical wavefront. These are the cylindrical wavefront. Finite distance source is incident on the narrow slit or cylindrical surface. Emergent wavefront are called as cylindrical wavefront. Next, plane wavefront. Plane wavefront. What are plane wavefront? Plane wavefront are wavefront from the spherical or cylindrical surface at infinite distance source. Wavefront from spherical or cylindrical surface. Cylindrical surface from cylindrical surface at infinite distance source. Infinite distance source, or infinite distance source, or infinite distance source of light is incident on the cylindrical or spherical surface. The source of light is incident from the infinite distance on the spherical or cylindrical surface. Emergent wavefront is called plane wavefront. When ray of light is incident from the large distance source or infinite distance source, the emergent wavefront is called plane wavefront. When ray of light is incident large infinite distance at the spherical surface, emergent wavefront is called spherical plane wavefront. The infinite distance source of light is incident on the cylindrical surface. Emergent wavefront is called cylindrical plane wavefront. What is the meaning of plane wavefront? When infinite distance source is incident on the spherical or cylindrical surface, the emergent wavefront is a plane wavefront. Emergent wavefront is a plane wavefront. Next, Eigens principles. Eigens principle. What is the statement of Eigens principles? The first principle is each wavefront is a source of secondary disturbance, and secondary wavelet originating from that point spread equally in all directions. The second principle, new wavefront advanced in the medium, it takes tangential forward direction to the secondary wavelets. You take the first principle, each wavefront is a source of secondary disturbance. Source of secondary disturbance, and secondary wavelet from this point. Secondary wavelet from this point spread equally in all directions. Spread equally in all directions. First principle. Second principle, new wavefront advanced in the medium. New wavefront advanced in the medium is taken tangential forward directions. Tangential forward directions to the secondary wavelet. Tangential forward direction to the secondary wavefront. New wavefront advanced in the medium. It's taken tangential forward directions, or it's taken tangential forward direction to the secondary wavelets. First principle, each wavefront is a source of secondary disturbance, and secondary wavelets originating from these points spread equally in all directions. Second principle, new wavefront advanced in the medium, it's taken tangential forward direction to the secondary wavelet. These are the second principles. How it's explained principles? By using the diagram. Explanation of the principle by using these diagrams. This is the source of light. Taken. This is the initial wavefront, AB. Each wavefront is a source of secondary disturbance according to the principle. These are the wavefront. Each wavefront is a source of secondary wavelet. Each wavefront is a source of secondary disturbance. And secondary wavelet originating from this point are spread equally in all directions. Like this. Secondary wavelets originating from this point are spread equally in all directions. These circles are secondary wavelets. These are the secondary wavelets originating from this point or spread equally in all directions. These are the secondary wavelets. In order to construct the new wavefront, draw the tangent to the secondary wavelet. This is the tangent. This tangent where A dash, B dash, A dash, B dash is the new wavefront. In order to construct new wavefront, according to the principle, the tangential forward direction to the secondary wavelength is called new wavefront. AB is the initial wavefront, A dash B dash is the new wavefront. This is the finite distance source. It's infinite. Finite distance wavefront. The source of light is infinite distance. They produces plane wavefront. The source of light is at infinite distance, like this. This is the plane wavefront diagram. This is the AB be the initial wavefront. In order to construct new wavefront, tangent drawn to the secondary wavelength, A dash B dash be the secondary wavelength. The distance of the source is infinite distance. Infinite distance from the source. The secondary wavelengths or wavefront from infinite distance source. These are the wavefront from finite distance source. These are the wavefront from finite distance source. Finite distance source. These are the infinite distance source wavefront. These are the finite distance wavefront. According to the principle, each wavefront is a source of secondary disturbance and secondary wavelength from these points spread equally in all directions. In second principle, in order to construct the new wavefront or new wavefront advanced in the medium, it takes tangential forward direction to the secondary wavelengths. It takes tangential forward direction to the secondary wavelengths. This is the expression of Eigens principle. Next, explain refraction of a plane wavefront by using Eigens principle. Explain refraction of a plane wavefront by using Eigens principle. Or to prove the Snell's law of refraction of a plane wavefront by using Eigens principle, or to prove the Snell's law by using refraction of a plane wavefront using Eigens principles. First, we take this is the xy be the refracting surface. What are refracting surface? Glass, water, or lens is many refracting surface are there. You consider xy be the one of the refracting surface. A plane wavefront is incident obliquely. A plane wavefront AB is incident on the refracting surface. Point A on the plane wavefront is incident on the reflecting surface. It's refracted along AE. It reflected along AE. I be the angle of incidence of wavefront point A on the refracting surface, or be the angle of refraction of A along AE, where we consider AB be the incident wavefront. Incident wavefront. Point A is the wavefront AB is incident obliquely on the xy surface. Point A on incident on the A, it reflected along AE. It reflected along AE. The time taken for secondary wavelength from B to C in rarer medium is same that of time taken for secondary wavelength from A to E in denser medium. The time interval between the time interval between the secondary wavelet to reach B to C in rarer medium is same that of time interval between the A to E in denser medium. In order to construct the new refracted wavefront, first you take the secondary wavelet, plane wavefront is incident on the refracting surface xy. The secondary wavelet from point A at E, time taken for secondary wavelet from A to E is same that of time taken for secondary wavelet from B to C at C, or in same interval of time, and secondary wavelet from A to E and secondary wavelet from B to C or in same phase. In order to construct the new refracted wavefront, tangent drawn to the sphere of V1t and V2t get new refracted wavefront. This is called refracted wavefront. When plane wavefront AB is incident on the refracting surface xy, the time interval between the time taken for secondary wavelet from A to E is same that of secondary wavelet from B to C in rarer medium. Both secondary wavelet from A to E and B to C are in same phase. In order to construct the new refracted wavefront, according to the Eigen principle, the tangent drawn to the sphere of V1t and sphere of V2t get new refracted wavefront. This is the angle I because of congruency triangles. This is the angle R. This is a 90 degree. This is a 90 degree. How to prove Snell's law? First, once again I will detail discuss about it. The plane wavefront from infinite source is incident on the xy refracting surface. The time taken for secondary wavelet from A to E in denser medium, time taken for secondary wavelet from A to E in denser medium is same that of time taken for secondary wavelet from B to C in rarer medium. The secondary wavelet from A to E and secondary wavelet from B to C are in same phase. In order to construct the new refracted wavefront, according to the Eigen principle, draw the tangent to E to C, get new refracted wavefront. C is the new refracted wavefront. How to prove Snell's law? By using right angle triangles. ABC is 90 degree. Define sine I in these triangles. It is a BC by AC, where BC is equal to V1t by AC. In second triangle, AEC is 90 degree. AEC is 90 degree. Define sine R in these triangles. It's equals to AE by AC is equal to V2t by AC. We take equation 1, take equation 2. Divide 1 by 2. Get sine I by sine R is equal to V1t by V2t. T get cancelled. Finally, it's also equal to sine I by sine R is equal to N2 by N1. According to Snell's law, sine I by sine R is equal to V1 by V2 is equal to N2 by N1. This is the proof of Snell's law by using refraction of a plane wavefront by using the Eigen's principles. Okay. Next, reflection of a plane wavefront by using Eigen's principle. Explain reflection of plane wavefront. Explain reflection of plane wavefront by using Eigens principle. Now you consider reflecting surface. Now you consider xy be the one of the reflecting surface. A plane wavefront AB is incident on the reflecting surface. Plane wavefront AB is incident on the reflecting surface. Point A on the plane wavefront is incident on the reflecting surface. It reflected along AE. It reflected along AE. Point A on the plane wavefront AB is incident on the reflecting surface is reflected along AE. Where this AB is the incident wavefront. The secondary wavelet from point A on the plane wavefront